Here we're going to discuss the employer's profit maximizing level of hiring. And so what we're going to have to do now is we're going to have to say, okay, we've determined the level of effort. Having determined the level of effort at the Nash equilibrium, how many hours of employment will the employer hire? That's what we have to ask. Okay, so let's see how that works. So the employer knows the combination WN over EN. That's the wages that they're paying for the effort that they're receiving at the Nash equilibrium. So having done that, they need to determine the hours, like I've said. So the hours of the worker's time, that is not what produces goods, right? So the effort is what produces the goods. So we have to distinguish between two things. Firstly, the number of hours hired, and then the total amount of actual work that gets done, which is devoted to producing goods. And that is what we call labor employed, or a combination of the hours multiplied by the effort, and those two things together give us labor. So labor equals EN times H. So that's like effort per hour times number of hours gives us what the labor is doing. Okay, so to determine H, what does the employer do? They make use of the demand function X as a function of price for the firm's product. Right, so the firm is producing a product, and we saw how that worked in chapter 9. With that product, what do we know? They use labor as a labor input into the production of that product. But now we say, okay, we've got to take the demand for this good as given, and then we know that the production function, which is used to produce the good, is a function of capital and labor. So X is produced by capital and labor. What does labor equal? Labor equals effort times what? Hours hired. Okay, so here, hiring is going to be equivalent to the number of hours hired. So you're paying an hourly wage, you're getting effort for that hourly wage that you're paying, you now have to determine how many hours to hire. Okay, so the figure that we're going to show in a second shows the employer's profit maximizing level of hours hired determined by the wage that they're paying per hour, which is given by the solo condition that we saw earlier, that MRS equal to MRT in the labor market condition. Okay, so here's the figure. So, let's pay attention to a few things. The employer chooses H where the marginal costs of an hour of labor, okay, which is WN, the wage that they pay, equals marginal revenue product of hours of labor hired. Okay, so notice what's going on here. We've got total labor hours hired by the employer, H, along on the x-axis. We've got the wage and the marginal revenue product of hours, which is equal to revenue times the effort that is exerted per hour. Okay, so what's going on here? We have two different curves, just to show you what two different Nash equilibrium levels of hours would be. Those two different curves are what we call the marginal revenue product of an hour of labor, okay, MRPH. Okay, so remember we've got H along the x-axis here, so the marginal revenue product of an hour of work is downward sloping. So in each of these cases, we're going to have a marginal revenue product of an hour of work curve that is downward sloping, intersecting with the marginal cost, and that's going to give us an equilibrium. So you might be thinking, what is a marginal revenue product of H, an hour? So think to yourself about it in the following way, right? When you're hiring people to work, what are they doing? They are producing the output that you sell. When they produce the output that you sell, what does that mean? Each hour of work is going to be contributing something to your marginal revenue in your selling of the good. And so we can talk about the marginal revenue product of an input. Here we're talking about the marginal revenue product of an hour of employment. In the next figure, we're going to kind of talk about the marginal product of labor broadly. But let's think about this marginal revenue product of an hour of work. What are we saying there? It's saying for each additional hour of work that you hire, that additional hour is going to add something to your total revenue. But what is happening to the price of the good as you produce more output? Like more hours that you hire, what does that mean? More output. With more output though, what's going to happen to the price? The price is going to go down. So what does that mean has to happen to the marginal revenue product of an additional hour of work? marginal revenue product must also be decreasing as we hire more people, because the price is going to go down as we increase our output, as those more people produce more goods. Hence, the marginal revenue product of an hour of effort is going to be downward sloping. And what we have here in both the solid green line and the dashed green line are two different marginal revenue products corresponding to an increase in the marginal revenue product, right? So if it was the case that we could have a slightly higher marginal revenue product, which is the second dashed line, what's that going to give us? It's going to give us a different Nash equilibrium for the same current wage that we're paying, right? Okay, so now, previous one, number of hours. What have we done here? The thing is that in our production function, we don't have hours hired, we have hours times effort, and hours times effort, that gives us total labor hired. That's what those three things are together, right? Well, labor equals effort times the number of hours hired. So because we use labor as the input into our production function, we think about the marginal revenue product of labor given the effort that we pay. Okay, so the marginal revenue product of labor is the change in total revenue associated with a small change in labor employed. Okay, so this figure is slightly different here. Notice what's happened on the x-axis. I've got a different x-axis to the previous figure. I've got labor used by the employer, L equal to En times H, whereas in the previous one it was just the H hired. Okay, whereas previously I also had W as the hourly wage that I would pay, I now have to think about the cost, the marginal cost of labor, as the wage that I'm paying for a unit of effort. That's back to this solo condition that we mentioned. Okay, so this figure presents the same information but in a slightly different way. What's happening is we're showing the marginal product of labor rather than the marginal product of an hour, which is what we saw in the previous figure. Okay, so it's labor employed, not just hours of labor employed. Okay, like I said, labor employed is equal to the total effort, effort times hours hired. Okay, I've already explained why we use L. If you don't remember, go back to yourself. Why are we using L here? Think about how we get our output. Okay, so when deciding how much to employ, we've got to weigh the marginal cost of labor against the marginal revenue product of labor. So it's MC equals MR. It's the same condition that we've always had with profit maximization, but here we're talking about a marginal revenue product of labor, labor equal to En times H, and the marginal cost of labor. The marginal cost is the wage for given effort that we're already hiring from the Nash equilibrium of the labor discipline model. Okay, so marginal cost, that's CL, in the Nash equilibrium here is going to be equal to 40, and that's CL equal to WN over EN. We set that equal to our marginal revenue product of labor. What can we see? If our marginal revenue product of labor is given by the solid green line, then what we have there is units of labor hired equal to 500 units. If the marginal revenue product curve had shifted out, what would that give us? It would give us a new number of Nash equilibrium units of labor hired equal to 1,000. Now notice something, right? Labor is equal to En times H. En, our Nash equilibrium effort, was 1/2 in the labor discipline model. So notice what's going on here. I'm going to jump back 2 slides and then we can see how this works. Okay, so notice here our Nash equilibrium number of hours hired was 1,000 initially, and over here 2,000 at the second Nash equilibrium. Now what do we measure in our next figure? We measure labor, which is effort times hours. Okay, so what do we see here? We see with our 2 Nash equilibria, Nash equilibrium 1, the number of hours was 1,000. What was effort? Was 1/2. 1,000 times 1/2 gives us total labor hired. In the other case, we had 2,000 and again effort of 1/2. What does that tell us about total labor hired? That's 1,000. And that's how the 2 graphs correspond to each other, right? We're seeing that hours corresponds to labor given the Nash equilibrium effort.